before we dive into our discrete and continuous probability distributions, let's just take a moment and talk about random variables. So a random variable is a numerical outcome of a random circumstance and is a fundamental piece of statistical analysis. Random variables allow us to make generalizations about an observed phenomenon based on the phenomenon's probability of occurrence. Remember, the whole point of stats is to take a sample, find out what's happening in that sample, and then try to extrapolate to the greater population. So what we need to do then is make those generalizations about things that we observe, and we're going to do that based on the probability of their occurrence. So each value of a random variable is associated with a probability to indicate the chance of a particular outcome. Random variables will always have some sort of distribution. So a lot of times in statistics, what we're doing is we're making an assumption about the type of distribution that a particular variable would have. And when we get into our Monte Carlo simulations in our prescriptive analytics, deciding what we should do, we will be looking more at using these different probability distributions in our simulations. All right, so let's dive a bit more into random variables. There are different types of random variables. There are discrete and continuous. And so we talked about how we are looking at discrete probability distributions and continuous probability distributions. That's because random variables are discrete or continuous. So a discrete random variable is a random variable that assumes only certain clearly separated values. So typically that's going to be a count. We'll talk about things like Poisson distributions. In a Poisson distribution, we're counting the number of occurrences, like how many absences do we have? How many birds did we identify? In comparison, we have continuous random variables, a random variable that can assume an infinite number of values within certain limitations. So these are typically measurements because it allows for us to have fractions. Okay. So we're going to be looking at discrete random variables and continuous random variables. So let's look at some examples of random variables. And then can you identify whether they are discrete or continuous? So if the number of students in the class with blonde hair, well, we can count that number. There's a limited number of options because you can't have fractions of people. And so here we have a discrete variable. A person's weight in pounds, well, we can have a fraction of a pound, so that can be continuous. The amount of money a store makes in a day, typically we're going to treat that more as continuous if we're going to accept pennies because you can have change. The occurrence of heads when 3 coins are tossed. We tossed the coin in the previous video. Remember that you could have 0 heads, 1 head, 2 head, or 3 heads when you did 3 coin tosses. So it's limited in the different options that we have. And so the coin toss is going to be discrete. One of the distributions we're going to look at is a binomial distribution. And so when you look at a coin toss, because you can only have heads or tails, that's going to be a binomial distribution. Whereas the Poisson distribution was a number of counts. Binomial is where it's essentially yes or no, true or false. If we look at the size of basketball players' feet, right, if we're going to measure those in inches or centimeters, measurements are going to be continuous. We could think about other things like measurements of time. How long does it take to run the Boston Marathon? Because we have fractions of seconds, we can measure that as continuous. Lengths of a field, diameters of a tree, these are all going to be continuous. Number of absences from work, number of students who earn a B, number of highway deaths, those are all counts. They are all going to be discrete. So just a brief comment here on interpretations of discrete and continuous variables. Although a random variable may fit the definition of discrete, it may be more convenient or realistic to treat it as a continuous random variable. As we said with like prices, for example, we're going to treat them more as continuous, right? Yes, it can't be any possible number because you only have it down to say a penny. But we will just treat it as continuous even though it is limited. Incomes, test scores, we often treat those as continuous. Even though all fractions aren't registered, we don't keep track of, like when we report people's income, we round it off to $1, right? Often we round it off to 100 or thousands of dollars. But we often will treat it as continuous, even though our record keeping isn't recording any possible number. Other times, rounding of continuous variables can make their values appear discrete, right? So we could round pounds, round height to inches, ages to years. So we'll treat them as continuous there. As a general rule, if the number of possible values is large and we're more interested in probabilities concerning intervals or a range of values, then we'll treat it as continuous. If we are looking at the probability of a certain value, and people or groups, whatever we're measuring, that it's likely that multiple observational units are going to have that value, so a specific value, then we'll go more discrete. If it's an interval or a range we care about, then we'll go continuous. So why treat them separately? Why distinguish between continuous and discrete? There are different ways that we calculate the probabilities of something is discrete versus continuous. And so, as I said, we have different probability distributions, whether something is discrete or continuous, because those probabilities are calculated differently. So when we look at continuous, for example, we look at things like the normal distribution, that bell-shaped curve, but that only really works for continuous variables where we can look at ranges of values. So for continuous random variables, we can't find probabilities for a specific outcome. Instead, we're looking for that range or interval. And for discrete random variables, we're looking at specific outcomes or numbers. So whether we're looking at discrete or continuous, from there, we can come up with a probability density function, often called a PDF, or a probability mass function, PMF. So these are ways to describe the probability distribution of a random variable. So as we get into these different types of probabilities and distributions, we'll come back to these probability density functions.